Hi everyone, welcome back to Ruma Education. Today we will go through 30 important MCQs from your string matching algorithm lecture. You will not only learn the correct answers but also understand why other options are wrong. So let's begin. In string matching, if text length is n and pattern length is m, how many possible shifts are there? Options: A. N plus m, B. N minus m, C. N minus m plus 1, D. N multiply m. The correct answer is C. N minus m plus 1, because the pattern can start at every position from 0 to n minus m, giving us possible shifts. A and B are wrong because they miss or add extra shifts. D is wrong because it's about comparisons, not shifts. The naive string matching algorithm compares pattern characters: A. Only until first mismatch occurs. B. At every shift position. C. Only once for the entire text. D. After computing hash value. Correct answer is B. The naive algorithm checks the pattern at each position in the text. D is wrong because it doesn't use hashing. That's wrapping up. The worst case time complexity of the naive string matching algorithm is A. Big O n, B. Big O m, C. Big O n minus m plus 1 multiply m, D. Big O log n. The correct answer is C, because for each possible shift up to m characters may be compared. A and B are partial and D is relevant here. Which situation case is the worst case for the naive algorithm? A. Pattern not found. B. Pattern found at first position. C. Pattern algorithm matches but fails at last characters repeatedly. D. Pattern longer than text. Correct answer is C. The algorithm wastes time when most characters match but the last one doesn't repeatedly. Select all applications of string matching algorithms. A. Text editors. B. DNA sequence analysis. C. Computer virus detection. D. Sorting numerical data. Correct answers A, B and C. Sorting is not string matching. Others are valid applications. Who introduced the Rabin-Craft algorithm? A. Donald Knapp and Vaughan Rat. B. Richard Kraft and Michel Rabin. C. Tony Hoare. D. Thomas Coleman. Answer is B. Developed in 1984 by Michel Rabin and Richard Kraft. Rabin-Craft algorithm uses which concept to speed up matching? A. Binary search. B. Hashing and modulo operation. C. Linked list traversal. D. Dynamic programming. Correct answer is B. Hashing and modulo operation converts string into numerical hash values using modular arithmetic. Advantages of Rabin-Craft algorithm include: A. Handles multiple patterns efficiently. B. Compares hashes instead of characters. C. Guaranteed constant time per character. D. Reduces unnecessary comparisons. Answers A, B and D. Option C is false. Hashing still has linear cost and possible collisions. In Rabin-Craft, a spurious hit means: A. Hash values match but characters don't. B. pattern is actually found. C. Pattern hash differs from window hash. D. No possible match. Correct answer is A. It's false possible caused by hash collision. To reduce the number of spurious hits in Rabin graph, we should A. Use smaller modulo Q. B. Use larger prime modulo Q. C. Reduce pattern size. D. Ignore hash matches. Correct answer is B. Use larger prime modulo Q. Larger prime modulo reduces hash collisions. Fewer spurious hits. When no spurious hits occur, Rabin graph runs in A. Big O n square, B. Big O n plus m, C. Big O n multiply m, D. Big O log n. Answer is B. Big O n plus m because it checks each text windows once and no spurious hits occur. In worst case, Rabin graph time complexity becomes A. Big O n squared, B. Big O n minus m plus 1 multiply m, C. Big O n plus m, D. Big O log m. Correct answer is B. Big O n minus m plus 1 multiply m. A finite automation is defined by 5 components. Identify them. A. Setup status. B. Start state. C. Accepting status. D. Input alphabet. E. Transition function. What is the purpose of this in a finite automation? A. Counting status. B. Handling modulo. C. Transition between status. D. Ending the pattern. Correct answer is C. Transition between status. If automation has no transition for a symbol, it usually A. Crashes, B. Moves to start state, C. Ignores the input, D. Accepts input by default. Correct answer is B. Moves to start state. Undefined transition usually return to start state. For pattern A, B, A, how many accepting status exist in its automation? A, 1, B, 2, C, 3, D, 4. Correct answer is A, 1. Only the final state after full match is accepting. Which algorithm is most efficient for long text with repeated patterns? A. Naive, B. Rabin graph, C. Finite automate, D. Linear search. Correct answer is C. Finite automate. Select true statements about Rabin graph. A. Uses hash comparison. B. May produce spurious hits. C. Never checks characters. D. Can handle multiple patterns. Correct answer is A, B, and D. The naive algorithm prints A. Match found at position for every value shift. B. Only first match. C. Total number of matches. D. None of the above. Correct answer is A. Match found at position for every valid shift. The pseudocode prints every valid shift. If text length equal 12, pattern length equal 4, how many shifts? A. 8, B. 9, C. 10, D. 12. Correct answer is B. N minus m plus 1. So 12 minus 4 plus 1 equal 9. Naive algorithm disadvantages. A. Repeated character comparisons. B. Poor worst case performance. C. Needs hash calculation. D. Good for small text only. Correct answers A, B and D. It doesn't use hashing. When P occurs with shift S in T, which condition is true? A. T. S to S plus M minus 1 equal P 1 to M. B. T. S plus 1 to S plus M equal P 1 to M. C. T. S plus M to S plus 1 equal P 1 to M. D. T. S equal P M. What is the correct answer? Correct answer is B. Slide index by plus 1 because arrays are 1 based in pseudocode. In Rabin graph, if two hashes match but string differ, what should happen? A. Accept as valid. B. Reject immediately. C. Reject by character comparison. D. Skip that window. Correct answer is C. Must verify characters to eliminate spurious hit. A finite automation for pattern AB has A. 2 status, B. 3 status, C. 4 status, D. 1 status. Correct answer is B. 1 start, 1 intermediate, 1 accepting. Which algorithms have worst case complexity bigger of n minus n plus 1 multiply m? A. Naive, B. Rabin curve, C. Finite automate, D. Merge sort. Correct answers A and B. If text A and pattern equal AA, how many valid shifts? A 1, B 2, C 3, D 4. Correct answer is D. Matches start at position 0, 1, 2, 3, 2, 4. Total. What is the main advantage of using finite automate? A. Easy to code. B. Works faster once transition table built. C. Useless memory. D. Avoid pattern preprocessing. Correct answer is B. Preprocessing makes later matching bigger of n. When do both Rabin curve and naive give some performance? A. All hits is spurious. B. Pattern small. C. Text small. D. Best case scenario. Correct answer is A and C. If finite automation reads each text character exactly once, total time is A. Big O of n multiply m. B. Big O of n. C. Big O of m square. D. Big O of n log m. Correct answer is B. Big O of n. Thank you for listening until the end. Have a nice day.